In this video, we go a little bit more in details of power spectral factorization for discrete time random processes which are void sense stationary using rational power spectrum. So we say a random process has a rational power spectrum if we can write and express as xx of z, which is z transform of r xx of, let's say, m, as a ratio of two polynomials. If the z transform autocorrelation function can be written as a ratio of two polynomials, we say is a rational power spectrum. So for a rational power spectrum, we can decompose this one, and we have seen that because this function should have a symmetrical property that xx of z shall be always equal to x of 1 over z. That means that any poles or zeros at zi should be also poles or zero at 1 over zi. Because if zi makes this guy 0, 1 over zi also makes this 0. Or if zi makes this guy infinity, 1 over zi also makes this infinity. So in that case, you can write and decompose this one in two functions. So numerator can be written also as product of two functions, and because of this property, because this is equal to xx of 1 over z and denominator. So L of z will be equal to n of z divided by dz, such that n of z and dz, they inherit all and only poles and zeros which are inside the unit circle. Okay, and regional convergence includes outside of the unit circle. So this guarantees that L of z is both invertible and causal. So the roots of n of z and dz's are also the roots of numerator and denominators of this. They shall be inside the unit circle. So whatever roots and poles of s of x of z are outside, there are roots and poles of the other term. So these terms take the roots and poles which are outside the unit circle, and the other one takes whatever is the inside. For example, if I have this function, the first thing I do here using this function, I take cosine of omega is equal to z plus z minus 1 divided by 2. So what I get is that Sx of z becomes 5 minus 4 times z plus z minus 1 divided by 2 and divided by 10 minus 6 times z plus z minus 1 divided by 2. And I then simplify, it becomes 5 minus 2z minus 2z minus 1, and then here I get 10 minus 3 times z, and then minus 3 times z minus 1. Obviously, you can multiply both numerators and denominator by z and then find a. So if you do that, you get this expression. So I get this function multiplied by z. Okay. So I get twice z to the power of 2, and then I get plus 5z, and then I get minus 2 equals 0. So this is second order polynomial. You find two solutions, z1 and z2. Remember that z1 and z2 are related, so this is always equal to 1. So if this relationship is not satisfied, then something is wrong. And then you do this for the denominator and front. So you find the poles and roots, and then you allocate whatever is inside the unit circle. So you see that if you calculate the root of this one, z becomes equal to 1 over 2, which is inside the unit circle, and here so is z1, and then p1 is equal to 1 over 3, which is inside the unit circle. So another pole z2 should be equal to, another pole p2 should be equal to 3, which is inverse of this one. So this power spectral factorization, this is the solution. So you have 1, 0, 1 pole. So the degree of this power spectrum is 1, 1. So this is the number of zeros, this is the number of poles. We call it AR degree 1, 1, number of poles, number of zeros. We'll learn about it in the next videos.